Hey guys, Dean Chase here with another geometry lesson for you. Good to have you all back. Let's just go ahead and get started with a word of prayer. Dear Heavenly Father, I want to thank you for today, goodness, Lord. I want to thank you for all you do. I pray that you'll be with my students. Thank you for this opportunity. We love you. In Jesus' name, pray, amen. Alright guys, so today we're going to be learning how to use postulates and diagrams. This is page 96, lesson 204 if you're following along in a book with me. Okay, let's get started. Let's get done with this lesson, you know what I'm saying? So, in geometry, rules that are accepted without proof are called postulates or axioms. Rules that are proved are called theorems. Postulates and theorems are often written in conditional form. Unlike the converse of a definition, the converse of a postulate or theorem cannot be assumed to be true. So, in chapter 1, you have learned 4 postulates. Postulate 1 was your ruler postulate. That's on page 9. Postulate 2, the segment addition postulate, on page 10. Postulate 3, the protractor postulate, on page 24. And postulate 4, the angle addition postulate, on page 25. So, here's my little blurb for you if you're following along with my class. What I would recommend you doing right now is pausing this, going and finding these postulates, and writing them down in the back of your book. Take like the last 4 pages of your notebook and start writing these down in your notes. Because the rest of the year, we'll be using this stuff. So from now on, when we learn a new postulate or theorem, you should write it down in the back of your book. Okay, let's learn our new postulates for the day. We got a ton of them, so here we go. We're going to learn postulates about points, lines, and planes. So postulate 5 says, through any 2 points, there exists exactly one line. Postulate 6, a line contains at least 2 points. Postulate 7, if 2 lines intersect, then their intersection is exactly 1 point. Postulate 8, through any 3 non-collinear points, there exists exactly 1 plane. Postulate 9, a plane contains at least 3 non-collinear points. Postulate 10, if 2 points lie in a plane, then the line containing them lie in the plane. Postulate 11, if 2 planes intersect, then their intersection is a line. There you guys go. Ton of stuff. But you can look back and take it in your notes, all that stuff, and follow along. Our examples are about these postulates today. So, algebra connection. Just a real quick blurb about how you used all of this last year when you were taking algebra, and you probably didn't even know you had geometry facts. So you have been using many of postulates 5 through 11 in previous courses. One example would be one way to graph a linear equation is to plot 2 points whose coordinates satisfy the equation and then connect them with a line, which says that through 2 points there exists exactly one line. So you know that line is the correct line. Postulate 5 guarantees that there is exactly one such line. A familiar way to find common solution of 2 linear equations is to graph the lines and find the coordinates of their intersection. This process is guaranteed to work by postulate 7. There you guys go. Little bit of how you've been using geometry all along and you didn't even know it. So here we go. Example 1. State the postulate illustrated by the diagram. So it says, if point A and B, then there's a line through A and B. So, what postulate says that if you have 2 points and then you have a line that connects them? What postulate deals with that? Well, that's postulate 5, and postulate 5 says through any 2 points there's exactly one line. Okay? That makes sense, right? Part B. If plane R contains points X and Y, then plane R contains a line that is made up of X and Y. What postulate dealt with a plane and a line and 2 points? Postulate 10 did, and it said if 2 points lie in a plane, then the line containing them lie in the plane. I feel like that's pretty straightforward. I hope it makes sense. If not, just look at the examples in your book, maybe re-listen to it. I don't know. Let's just keep going. Example 2. They want us to use the diagram to write examples of postulates 6 and 8. So the first thing we need to do is go back and let's let me read postulate 6 for you, because we'll do that one first. Postulate 6 says a line contains at least 2 points. So on here, anywhere, do you see a line that contains at least 2 points? Well, there's only one line that I can see, and it's line L. And it contains points R and S. So postulate 6, we could use it to write an example of postulate 6. We'd say line L contains 2 points R and S. At least 2 points R and S. Excellent. Postulate 8 says, through any 3 non-collinear points, there exists exactly 1 plane. So, if we look, 3 non-collinear points, once again, on our diagram, we only have 3 points, R, S, and W, and they're all contained in plane M. So, through non-collinear points R, S, and W, there exists exactly 1 plane M. Okay? Hope that makes sense. I hope, yeah. You've got this. You guys are doing great. Let's just keep going. So, interpreting diagrams. When you interpret a diagram, you can assume information about the size or measure only if it is marked. So, it's really easy to look at this and be like, oh man, AHB looks like a 90-degree angle. But you cannot assume that unless it was marked by a 90-degree angle. So here are a bunch of different things we can assume and things we cannot assume. We can assume all points on here are coplanar because they all lie in plane P. Okay? We can assume that angle AHB and BHD are a linear pair because they make up to form a single line. Okay? We can assume that AHF and BHD are vertical angles because we could physically see that they are vertical angles. We can assume that AH, J, and D are collinear because they all lie on that line. We can assume that AD intersects BF at point H because you can see that. So you can assume what you can physically see. But things you cannot assume would be that GF and E are collinear because there's not a line that goes through them. You cannot assume that BF and CE intersect. We don't know if those lines maybe go on for eternity and intersect. We don't know. We also don't know that they do not intersect. We do not know that they're parallel lines, okay? We cannot say that because there's not enough information given. We cannot say that BHA is congruent to BJA. We don't know that these two angles are congruent because that information is not given to us. We cannot assume measure or size. We cannot assume that AD is perpendicular to BF. Okay? We could have, if, like I said, if there's a little 90-degree box there, but there isn't. Okay? And we cannot assume that the measure of angle AHB equals 90 degrees. So, here, example 3. Sketch a diagram showing FH, ray FH, is perpendicular to segment EG. So, the first thing I'm going to point out is we really need to be careful and make sure we're looking above our letters to see what we're actually drawing. We're drawing a ray and a segment, okay? And it needs to intersect at its midpoint M. Okay, so I'm going to go ahead and draw ray FH, and segment EG. And they all intersect at M, okay? Now, we know that M is the midpoint, and M is the midpoint of EG. And the reason we know M cannot be the midpoint of FH is FH is a ray. How are you ever going to divide infinity perfectly in half? Half of infinity? I don't know. I can't count that high, and I'm a mathematician. So, we know that we are splitting the segment perfectly in half. Okay? It was really awesome. Today, one of my students actually tried drawing the ray as midpoints, using midpoints on the ray. And I hadn't even considered it or thought about it that way. That's what's really cool about working with people. You always get to see different perspectives. But anyways, that was a rant. Let's keep going. perpendicular figures. A line is perpendicular to a plane if and only if the lines intersect the plane in a point that is perpendicular to every line in the plane that intersects it at that point. So in the diagram, a line perpendicular to a plane must be marked with the right angle symbol. So if you look, line T here, line T, for it to be perpendicular to plane A, it has to be perpendicular to P and Q. And it is marked perpendicular to P and Q. If one of these, here I'll shade it out, if one of these was not drawn, we could not assume that T is perpendicular to plane A. We just wouldn't know. It has to be perpendicular to every line it intersects at a point. So, example 4, our final example, and then we're done. Which of the following cannot be assumed from the diagram? So we're just going to go through it. Can we assume that A, B, and C are collinear? A, B, and C. Yes, they all lie on the same line. So we can assume that. I'm going to do that with a green check mark. Can we assume that EF is perpendicular to line L? And we can, because it is labeled perpendicular with the right angle symbol. So, once again, a green check mark. Can we assume that BC is perpendicular to plane R? BC, plane R. And we cannot. BC is not labeled perpendicular to either of the lines contained in plane R. We would have to have a drawing of a right angle symbol here and here. And we don't have either of those, so we cannot say that BC is perpendicular to plane R. Can we say that EF intersects AC at B? EF intersects AC at point B? We can. Can we say that line L is perpendicular to AB? L and AB. We cannot. There is no perpendicular symbol there. Right angle symbol. Points B, C, and X are collinear. B, C, and X are collinear. We don't know that because this line doesn't cross through X, so we cannot say that it does. So we cannot assume that. Alright guys, that's the whole lesson. It wasn't too shabby. It's really good to be working with you guys. I hope you all are doing good. Please feel free to like and subscribe so you know when I'm posting new videos. Yeah, I guess that's all for today, guys. See ya!